All the other functions you deal with, x squared, x cubed, e to the x, etc., have an infinite domain, meaning you can plug whatever you want into them. That makes them a lot more flexible and overall a lot easier to work with. But our trig functions only work when theta is between 0 and 90 degrees. So the question is, how can we extend that domain of 0 to 90? And as we look at the triangle, you can kind of see the answer. You see how right here, when theta is really big, like 89.99 degrees, basically the biggest that it can be in order to still count as a right triangle? Well, what if we just went a little bit further? You can see that we'd break the normal right triangle and it would actually now be obtuse. But if we allow that to happen, we can sort of just keep going counterclockwise around the circle, the unit circle. So there's a logical way that we can extend past that 90 degrees, but the problem is that we don't really have a right triangle anymore. So SOHCAHTOA doesn't really work. Or does it? The trick is that we don't use this angle to build the right triangle. We use something called the reference angle. And when we do that, we can build it in the second quadrant by just dropping a line straight down and using this reference angle for the right triangle. And that works for the entire second quadrant. And if we keep going into the third quadrant, we can do a similar thing. It's just that the way that we get the reference angle changes a little bit. In the third quadrant, we just have to drop the line up towards the x-axis rather than down like we did in the second quadrant to complete a full right triangle where SOHCAHTOA works again.